Good afternoon. I am Paula ACUñA, optical designer in DeltaLIGHT. I am delighted to be here sharing some of our solutions, even on a digital manner. Is a nice initiative of LPS to have this conference, even with these conditions, yet digital. DeltaLIGHT is an architectural lighting company located in Belgium, in the West Flanders region. And it has been founded since since the year 89. Here in the headquarters, we work nearly 300 people, of which 30 we are dedicated to the research and development of new products. And worldwide, we are mainly in all continents, and we have developed so far more than 100,000 projects. Here in DeltaLIGHT, as mentioned, we have our R&D division. At least for the optical parts, we have optical design capabilities, as well as measuring capabilities with near field goniophotometers and far field goniophotmeters. Okay, as an architectural lighting company, we try to bring solutions to different segments, namely residential, retail lighting, offices, art and museums. And the topic that brings us to this point is actually the topic of glare. Glare, we all in the lighting business, we are constantly facing equations for solutions which are glare-free. And glare, as we talk in the indoor lighting context, we are talking mainly of discomfort glare. And discomfort glare is mainly caused by large contrasts of luminance within our field of view. Here on the screen, we see different images where we have lighting on the ceiling, and the lighting is created a very large contrast with respect to the background luminance. So as a lighting company, we try to bring solutions which are addressing this problem. Today, we will discuss how is it quantified the day of today discomfort glare when we do the artificial lighting with LEDs. How is then the ideal lighting concept, and what is proposed by DeltaLIGHT? So let's start by talking about discomfort glare. So the discomfort glare has been defined, a method to quantify it in the year 95, when we were mainly having completely different light sources, such as fluorescent lamps, halogen lamps, whose brightness or luminance was much smaller than the luminance that we may have the day of today with LEDs. Yet, the UGR is a formulation that considers the luminance of the luminaire, the luminance in the background, the solid angle that is subtended between from the eye of the observer up to the luminaire, and the position of the observer with respect to the luminaire. In this formula, or in this method, it's assumed that the luminance of the luminaire is uniform, which, as we will see later, is not always the case, certainly with LED-based luminaires. Even with luminance uniform luminance luminaires, we may have still a large contrast between the luminaire and the ceiling, as we see here on the left panel, is a lighting concept that might still have glare in excess. So, as we saw in the previous slide, one way to reduce the glare is by increasing the luminance in the background. And that can be done by adding some uplighting in the lighting concept. Now, if we are not talking about uniform luminance luminaires, but non-uniform, it has been shown by different studies that the correlation between the UGR and the visual perception of different observers differs or has a very low correlation for light sources which are not uniform in luminance. So when we have non-uniform luminance luminaires, different methods have been proposed. And so far, the CIE has proposed a technical document to recalculate or adjust the UGR for non-uniform luminaires. Namely, is needed to reconsider the effective luminance emitted by the luminaire, and also to rescale the emitting area of that light emitting part. In order to do that, it's necessary to have a quantification of the luminance from different directions, and to quantify from a luminance map what are the pixels for which the luminance is above a given value. It's said that to affect the glare, luminance values above the 500 candelas per square meter are already relevant and should be considered in the determination of this effective luminance. For further details about the calculation or adjustment process of the UGR, I invite you to have a look to the technical document of the CIE. This said, we can talk about which will be the ideal lighting concept. As we know that it's important to have reduced contrast between the luminance of the luminaire and the background luminance, as well as to have a luminaire whose uniformity is as high as possible. So I will propose two ideal lighting concepts. The first, these two lighting concepts, what are trying to address is to minimize the luminance at critical angles with respect to the field of view of the observer. This could be addressed at least by these two manners. The first, having a uniform luminance where the intensity distribution of such a luminaire is minimizing the light emitted at angles above 45 degrees with respect to the horizontal of the observer. And second, a luminaire whose emitting surface is still compact, perhaps not completely uniform, but is completely out of the field of view of the observer, yet with a high efficiency. Let's start by the first. So the first, we say to have a light source which is as uniform as possible, emitting luminance, and whose light intensity distribution cut off the light for, or minimizes the light for angles above 45 degrees, as the light distribution that we show here at the left side. So that will be the first concept. This is not an innovative concept. Several companies are already offering this kind of solution. But yet, a second possibility will be to have a luminaire, which is emitting light, again, still on the same directions, but is completely out of the field of view, yet with a high extraction efficiency. And that is what we want to propose with DeltaLIGHT. So the characteristics of a downlighter, or the expected parameters, will be luminaire whose beam angle is adjustable, and is adjustable at least between 26 degrees and 50 degrees. Is also adjustable in direction, or has the possibility to tilt it. Has a considerable lumen output, such that there are enough illuminance values for a given task, but still there is a good thermal management in miniaturization trend. To have adjustable light emitting color for the topics that we have seen the last time, how the color could affect the non-visual tasks of human beings, and also to have to be glare-free. So DeltaLIGHT, in a joint development with Dean Skira, we have formulated a concept which is based on the pinhole concept, and consists of a luminaire that is hidden behind, or positioned behind the ceiling. And on the ceiling, what we are going to have is just a very small opening of 10 millimeters by which all light, or the majority of the light, is going to escape. And of course, trying to achieve all possible requirements that a downlighter should have. This concept we have achieved by having different construction blocks, starting of course from an LED as light source, followed by a collimator, then having a focal zooming system, and then a focusing system, yet with the possibility to get rid of the color aberration. We have found a solution, and as we implement that solution, it's amazing to see how the light emitting surface is completely out of the field of view, but yet we have light on the object that we want to illuminate. So this will be the rendering for a 26 degrees. But also our system allows to modify the beam angle to values between 26 and 50 degrees. When we are having a beam of 50 degrees, we manage still to extract the majority of the light of the system. One important aspect of this luminaire is that it should also be tiltable, but preferably that the light output as well as the beam angle remains unchangeable by tilting the luminaire. And that we have achieved by positioning or aiming to that opening of 10 millimeters to have this as a focal point, and then it's possible to turn the luminaire to different directions and yet have the majority of the light extracted. Here we present the performance rendered for different tilting directions for the narrow beam, as well for the wide beam. We have developed then a concept from which we can extract up to 500 lumens delivered when we supply this fixture with 11 watts. We have a solution that is color aberration free. Of course, is glare free, since we don't really see the emitting surface. And all this functionality is covered by a patent at this moment. So as to summarize, we have defined an ideal lighting concept as a luminaire whose emitting surface is completely out of the observer, but yet is having a high efficiency. We have achieved this, and we have also managed to have this luminaire with a zoom functionality, yet with the maximum light extraction efficiency. And this, both the zooming as well as the light extraction efficiency, is not affected by the tilting function of the luminaire itself. So we thank you for the opportunity to allow us to share this concept, and we hope that you can enjoy the application of the concept. I will be pleased to get your questions or comments via my email address. Thank you very much, and stay safe.